Welcome to Brain Vision.
All right, let's look at equations for the family of linear functions that have a slope of 2. So we know that all equations of lines take on the form y equals mx plus b if we want to put them in slope-intercept form, and m is the slope. So we're saying that we have lines that have an m value of 2, a slope of 2. So we could write equations of this form. Y equals 2x plus b. B stands for the y-intercept, and that's going to change depending on the line. We don't have to use a b there. We could use any letter we want to stand in for that y-intercept. Now let's take a look at the graphs of several of these. So suppose we had y equals 2x plus 0, just the line y equals 2x. It would have a y-intercept of 0, a slope of 2, so it would look something like this. Let's say we had y equals 2x plus 1. It's going to be parallel to the line I just drew, and it has a y-intercept of 1. Same slope. Let's look at y equals 2x minus 1. It has a y-intercept of negative 1, same slope, so it's going to be parallel. That didn't look too parallel. We'll try that again. One more time. Okay. There we go. Now for part B. We want an equation for the family of functions that all go through the point 2, 1. Basically, when you see f of 2 equals 1, that means the point 2, 1. So if we take our point-slope form, which is y minus y1 equals m times x minus x1, and if we substitute the point 2, 1 in for x1 and y1, we'll get an equation that looks like this. Y minus 1 equals m times a quantity x minus 2. So this represents the family of functions that all go through the point 2, 1. Now if we want to change that into slope-intercept form, we could go ahead and distribute the m, and then we could add 1 to both sides. But I think it's more informational if we leave it the other way. All right, let's sketch several of these graphs. So we want lines that go through the point 2, 1. So we locate the point 2, 1, and then we just draw a whole bunch of lines that go through that point. We could have this line, we could have this line, we could have this line, we could have this line. There's infinitely many possibilities. Lastly, we're going to combine both parts. So we want the function that has a slope of 2 and goes through the point 2, 1. So let's go back to that point-slope form again. Y minus y1 equals m times x minus x1. And let's substitute the point 2, 1 in there. So y minus 1 equals, we're also going to substitute the slope of 2 in there. So y minus 1 equals 2 times the quantity x minus 2. Now this is the equation of the line. We could leave it like that, or we could change it to slope-intercept form. First by distributing the 2, and then by adding 1 to both sides. So we have y equals 2x minus 3.